This next example is a good example where we can put in place our see, think, wonder approach. So what do you see when you look at this question? Well, obviously there's a little description, which is still really important. Clearly there's a table, and you must be becoming quite familiar with the idea that the information would be presented in a table. So I think they're the obvious things I see. I hope that you would start to think that, well, I guess you can't do a lot of thinking until you've read the words. It says a photocopier has an initial value, 13,200, depreciates by 2,200 per year. The depreciation schedule shows the accumulated depreciation and value of the photocopier. So you might be thinking, I don't know what accumulated depreciation means, but hopefully you do have some understanding of the word accumulate. And to accumulate means to build up. So each year we add on another amount of depreciation, and over extended time, you've accumulated a lot of depreciation. You might be also starting to think that no equation is given. Would you use an equation here? Which equation would you use? And is it a straight line depreciation example? And hopefully you realise it is, because it actually says it's depreciating by the same amount per year, which is the requirement for a straight line depreciation situation. So, and wonder, will they possibly ask you to get the equation? Will they possibly ask you to draw a graph? So, looking at the questions, what's the value of the photocopier at the end of the 4th year? Fairly gentle sort of question. Period for, here's our accumulated depreciation. Now, paying attention now to the detail of the table. And we can see these are numbers that are building up, adding on to each year. Value of the photocopier is coming down, and at the end of the 4th year, end of the year, 4 years, it's 4,400, which you see I've got there. C, what is the total depreciation at the end of the 5th year? Well, total depreciation is the accumulated depreciation, so we need to be here, which is $11,000. Then when we look at C, draw a graph. We were wondering whether this would be the case, and D is write down the equation. I've included the answer for part C in drawing the graph. Just a few things I'd point out that you must make sure you do on your graph is that, excuse me, you show years on your horizontal axis, and we need to go to at least 6. Your vertical axis is your value. This is a very appropriate scale, so we're going up by 2000s. You may be slightly estimating where your 13,200 actually sits on your axis, but make sure that this is really the easiest point to plot, that by the time you get to 0, you're up here at 6 years. You really only need those 2 values. So try to make that point as accurate as you can. This point is very easy, 6 and 0. Make sure you're using a ruler to mark your scale on both axes, then draw your line. In D, they're asking you for the equation. We know the equation is of the form S equals V naught minus D times N. We need values for V naught and for D. We know from our understanding of V naught as the initial value, we were told that The purchase price was $13,200. So our equation starts $13,200 minus. And that's not going to vary. That is the price it was. That can't change. The amount it's depreciating isn't changing either. That is $2,200 per year. And we've got that times n, the number of years.